Okay, so in this first question, you're basically asked to fill in the table below. So let's go through how to do that. And basically to start off, I'll just scroll down a little bit so we can see the whole thing. There we go. To start off, you need to know the symbols and the names of the first 20 elements. So this one is hydrogen, helium has the symbol He, lithium, beryllium has the symbol Be, boron, symbol B, carbon has the symbol C, nitrogen, oh, misspelled that one, nitrogen, oxygen, O, fluorine, neon, magnesium, Mg, aluminium, silicon, Si, this is phosphorus, so I misspelled that one slightly, sorry, and aluminium too, sulfur, symbol S, chlorine, Cl, argon, is symbol Ar, potassium is symbol K, and calcium, Ca for calcium. So one really important thing is that if they have two letters like silicon or like calcium at the end here, the first one is capital and the second one is lowercase. If it's just one symbol like sulfur, if it's just one letter, then it's just S. And that just tells us, for instance, that chlorine here is actually not carbon and iodine, but it's one thing, it's chlorine. So that there's no confusion. Alright, so the next thing is we need to get into how do we figure out what some of the missing numbers are. And you should be able to use information from the table to basically figure this out. So the first key thing is basically the atomic number, the number of protons, and the number of electrons is always the same. And so there's a way we remember this. As I say, it's P. Alright, like the peas you eat, P-E-A, and then for the second bit, when we're going to look at how do you work out the number of neutrons, you need to remember the word man, so P-man. But for the P part, it's protons equals electrons equals atomic number. So the protons, the number of protons, the electrons, and the atomic number are all the same thing. Alright, so those three things here, the atomic number, the protons, and the electrons will all be the same. And in fact, the electron configuration here, which is how the electrons are organized, we can use that to figure out the number of electrons too. So let's go through and fill out, let's go fill out those three things. The atomic number, the number of protons, the number of electrons, and the electron, we can use it, well, let's fill in those three. Some of them we might need to leave blank, we'll come back to it, but let's do as many as we can. So, essentially, if we have a look, sorry, just go back to my pointer. There we go. Alright, this one, it's got one atomic number 1, so it must have one proton and one electron. Helium has 2 protons, so its atomic number must be 2, it must have 2 electrons. Beryllium, alright, we can't figure that, we don't know the protons or the neutrons, so we'll come back to that one. Alright, boron, atomic number 5, so 5 protons, 5 electrons. Carbon, 6 protons, so atomic number 6, and 6 electrons. So these three columns will always have the same number. Nitrogen, okay, we can see actually here the electron configuration, we've got a total of 2 and 5, means we've got a total of 7 electrons, which means 7 protons and atomic number 7. Alright, oxygen, atomic number 8, so we've got 8 protons and we've got 8 electrons. Fluorine, 9 protons, means atomic number 9 and 9 electrons. Neon, we can see here we've got 10 electrons total from our electron configuration, so we've got 10 protons and atomic number 10. Magnesium here, we've got 12 protons, so it must be atomic number 12 and 12 electrons. Silicon, can't quite figure that one out yet, we'll come back to it. Phosphorus, atomic number 15, so we've got 15 protons, 15 electrons. Sulfur, 16 protons, so it must be 16 there and 16 there too. Chlorine, 17 electrons, so we'll have 17 protons, and the atomic number is 17. So for atoms, the atomic number, the number of protons, and the number of electrons is always the same. If we add all these up, it's got 19 electrons total. Oops, sorry, that just skipped down a little bit on me. If we add all these up here, we've got 19 electrons total, and that means we've got 19 protons and atomic number 19. Calcium, atomic number 20, 20 protons, 20 electrons. Look at that, bam, we filled in most of our table. Alright, so the next bit, so just remember P, protons, electrons, and atomic number. All the same number, we can use any one of those to figure out the other two. Alright, so how do we figure out the number of protons if we don't have one of those things? Well, it actually is based on the mass number. So maybe let's actually start with that. What is this funny mass number? The atomic number is literally how many protons it has, and that's why it's the same as that. Alright, and an atom will always have the same number of protons as electrons, so they're all going to be the same. But what is this mass number? Well, the mass number is actually how many protons and neutrons it has total in the middle of the atom. So we can work out the mass number by totaling up the number of protons and neutrons. So if we have a look, let's go through and do all the ones that we can. Alright, let's go through and do all the ones that we actually can. So here I don't have my protons, so I'll skip that one. We've already got that one here. So protons and neutrons, adding these two together here. Alright, protons and neutrons total is 11. Adding the protons and neutrons, how many things do we have total in the middle of the atom? Will be 12. So my mass number here, adding up what's in the middle of the atom, the protons and neutrons, 14. Alright, adding up what's in the middle here, we're going to have 20, mass number 20. And so we filled in most of those. So again, we come back to this problem. We didn't quite know the atomic number of some of our, one of my atoms, like here, we didn't have the, sorry, this one here, brewing, we didn't have the atomic number. So how can I figure this out, which is the number of protons, number of electrons here? Well, if we know there are 9 things in the middle of the nucleus, it's got 9 protons and neutrons, and 5 of them are neutrons, we know that 4 of them must be protons. We know that these two numbers here have to equal the mass number. So I've got 5 plus whatever would go here has to make up 9. So if I put a 4 there, 5 and 4, this adds up to 9. Alright, okay, so we know these two numbers have to equal that. Alright, and so we know the atomic number is the same as the number of protons, V4, and the electrons is the same again. Alright, so for the mass number, alright, what you need to do is realize that the mass number is what we get when we add up these two numbers. You know, when we add up these two numbers, we'll get the mass number. So it works for both protons and neutrons if you need to work them out. For instance, here, how many neutrons does it have? Well, if these two things need to add up to 1, we must have 0 neutrons. 1 and 0 adds up to 1. Or in this one here, 2 plus something gives us a mass number of 4. So we know it must be 2. 2 and 2 will give me 4. Alright, what do we have over here? Well, we've got the atomic number 3, so it must have 3 protons. 3 and 4 gives me 7. Alright, we come down here. 8 and something gives me 16, so I know I need another 8 in here. 8 plus 8 gives me 16. 9 plus something gives me 19. Must be 10. Alright, so just a quick recap of what we've done so far. The atomic number is the same as the number of protons, is the same as the number of electrons. Alright, so this column here, this one here, and this one here will all have the same number of them. And we can even use the electron configuration, total up the number of electrons to get the electrons, which we can then use to get the other two. Alright, for the mass number here is equal to the protons plus neutrons. So the total of these ones here, we add all those ones up together. And so if we've got a gap in one of these, we can kind of figure out, well, how many more do we need to equal that mass number? So what we're doing there is, for instance, if we do another couple, these two here need to add up to 24. So I need another 12 there. 12 and 12 adds up to 24. Alright, so this next one, we've got the atomic number is 13, so I should have put in protons will be 13, electrons will be 13. Alright, and again, we can look at here then. What two numbers need to go here to add up to 27? Well, we're going to need 14. 13 and 14 will add up to 27. What number goes here? What are we going to add to 14 to get 28? Well, we're going to have 14 there to get 28. And now that I know my number of protons, I can put the atomic number as 14 and the number of electrons is 14. Alright, so remembering that those three are the same. Alright, and this one here, 15 plus what gives me 31. Alright, so it's going to be 16. Alright, now what you're basically doing, a little bit of, if we do a bit of algebra, if you're okay with algebra, is you can also say take the big number minus this number. So 32 minus 16 equals 16. And we can double check that. If I add these two together, do I get 32? Yes, I do. So 35 take away 17 will give me 18. Do those two numbers add up to 35? Yes, they do. Alright, so we can add those up. Now for this one, I've got two blanks. How do I work this out? That's right, my atomic number is the same as my number of protons, same as my number of electrons. So we do that one first. Alright, and now we have a look at what two numbers do I need here to add up to 42. So I can think how much more do I need to get to 42, which is 22, or I can think 40 take away 18 gives me 22. So these two numbers now add up to the mass number. Alright, 39, so 19 plus 20, or 39 take away 19 gives me 20. These two numbers add up to 39. Alright, and down here 20. So 20 plus 20 will give me a mass number of 40. So quick recap one more time. The atomic number, the number of protons, and the number of electrons are all the same number. They'll be equal. The mass number here will be equal to the total of the protons and neutrons added together. Alright, and you can actually that means you can actually go the mass number take away the number of protons, or the atomic number, will give you the number of neutrons. Alright, so this mass number is always the big number. It's because it's the combination of these two. And if you're missing one of these two, just think, how much do I need there so that these add up to the mass number? Alright, last little bit, the electron configuration. Alright, this is basically how are the electrons arranged. And the thing you need to remember here is that basically the first shell of electrons, the first layer holds 2, the next one holds 8, and then we can hold 8 more, and any leftover ones go in the next shell. Sometimes we put a 2, but it can actually hold more than 2. We're just not going to go any further, any bigger than that. Alright, so we look at the first one, and we've only got one electron. So that one electron just sits there on its own. The next one, we've only got 2 electrons, so they sit there on their own. Now in the first shell, lithium has 3 electrons, so we put 2 of them in the first shell, and 1 of them into the next shell. Beryllium has 4, so we put 2 in the first shell, and we've got 2 left over that go in the next shell, so that adds up to 4. Boron has 5, so it'll be 2 and then 3, 2 and then 4, 2 and then 5. Oxygen has 8 electrons, so 2 and then 6. Fluorine has 9 electrons, so 2 and then 7, that adds up to 9. Neon 2 and then 8, it's got 10 electrons. Sodium's been done, has 11, so 2, 8 and then 1. Magnesium has 2 and then 8, and then that shell's full. How many have we used so far? We've got 10 here. 2 and 8 together is 10, so we need 2 more on the end. Alright, 13 electrons means 2, and then 8 in the next shell, and 3 in the last shell. So 2, 8, 4, forgot my comma, 2, 8, 5, 2, 8, 6. 17 means 2, 8, 7. 18 means 2, 8, and then 8. That adds up to 18. And then that shell's full, so when we start a new shell, it goes 2, 8, 8, 1. And my last one here, 20 electrons means 2, then 8 in the next shell, 8 in the next shell, and 2 in the very last shell. So the first shell we always fill up from the first shell, the inside shell, towards the outer shells. The first shell only holds 2, so if you've got more than that, they start to fill up the next shell, which holds 8. The next shell holds 8, and the next shell after that, well, any you've got left over you can put in there. It does actually hold more than 2, but we're not going to go any bigger than that. You only need to know the first 20 elements. Cool, well I hope that made sense. So a quick recap just of the whole thing. Alright, just remember your atomic number, the number of protons, and the number of electrons are all the same. You can use the electron configuration to work out how many electrons you've got, but these three things, P, protons, electrons, atomic number, are all the same. So if you've got one of those numbers, you can fill in the other two. Alright, the next thing you've got to remember is that the mass number, alright, is the same as the protons and neutrons. The mass is how heavy the atom is, and because electrons are so tiny, we don't bother counting them. We just add up the number of protons and neutrons. So if you're missing the mass number, add up these two. If you're missing one of these two, ask yourself, how much do I need there? How many would I need there so that these two add up to the mass number? So for instance here, if we've got a mass number of 4, and I didn't know what this one was here, if I scribble it out, I could go, what do I need to add to 2 to get to 4? Well, I need another 2, and so 2 plus 2 is 4. Alright, the other way you can remember it is using the word man. Mass minus atomic equals the number of neutrons. So P man. Protons, electrons, and atomic number are all the same. Mass number minus atomic equals the neutrons is man, P man. Some people find it helpful to remember it that way. Okay, if you're stuck on any of that, just rewind to the video, and where I explain. If you jump along the bottom, speed it up, go forwards or go backwards, you'll be able to see where and what I'm filling in. And if that's the bit you're stuck on, go to the part of the video where I'm filling in the column you're having trouble with. Okay, so the names and symbols, you just got to remember those, but there is a way to figure out the rest of these things. Hope that was helpful, and good luck.